Okay, I'm going to work some of the problems from 6.3 that we did in class. Let's see, 32. 32 says the sine of 3x equals -1. So we have first question is we have one trig function. How many trig functions? We have one. When there's only one, we isolate it. Well, the sine is already by itself. So the next thing to do is do the inverse sine. So we do the inverse sine of both sides. That gets rid of the sine. So now we have 3x equals the inverse sine of -1. Remember, that means what angle has a sine of -1? Well, we know sine is y over r, so we're looking for y equals -1. Well, the only place y equals -1 is right down here. So our angle is, you could use a -π/2 or a +3π/2, it doesn't matter. Let's say we use a -π/2. And normally on inverse sine, you have to do two quadrants, but since there's only one place where sine equals -1, we don't have to worry about that here. So -π/2 plus 2πk. Now, the next step is we want to get x by itself, so we divide everything by 3. Well, if we divide by 3, -π/2 divided by 3 is like multiplying by 1/3, so that's a -π/6. We also have to multiply that by 1/3, so that's 2/3 πk. Well, now we want to find everything that fits between 0 and 2 pi. Well, we start with -π/6. There's no negative, so that doesn't work. Now, if we're going to add 2/3, since we're in sixth, 2 over 3 is the same as 4 over 6, so 4/6. So we're going to add 4/6. So if we take a -π/6 plus 4/6, that's 3/6 pi. Well, that's the same as 1/2 pi, and that fits in there. So that was 3/6. If we add 4 again, that's 7/6. That fits in there, so that works. If we add 4/6 again, we get 11/6. Well, 2 pi is 12/6, so 11 just barely fits, and that's our three answers. Okay. Let's see, another one we did was 33. So 33 is the sine of x over 2. So if you look at this one, there's a sine on each side, and notice it's exactly the same. Well, normally in an algebra problem, if we had a same thing on both sides, we'd move them, try to get them, put them together. So let's take this sine of x over 2 and let's add it to the other one to move it to the other side. So if I have a sine of x over 2 and another sine of x over 2, that's 2 sine of x over 2, and we're left with radical 2 over here. So now we have a single trig function, just sine. So we want to isolate it. We need to get rid of the 2. If we divide both sides by 2, we get radical 2 over 2. Now that may not look familiar, except when these numbers here match, we can divide top and bottom by radical 2. So radical 2 divided by radical 2 is 1. 2 divided by radical 2 is radical 2. That looks a lot more familiar. Now the next thing to go is the sine. So to get rid of sine, we do the inverse sine of both sides. So that gets rid of the sine. Well, now we have pi over 2 equals the inverse sine of 1 over radical 2. So that means what angle has a sine of 1 over radical 2? Well, opposite over hypotenuse, the only one we have with a hypotenuse of radical 2 is a 45, 45, 90. I put a pi there. That should be an x. I'm sorry, I got carried away there. That should be an x. Sorry, x over 2 equals, and that really probably got you confused. Now, that was an x the whole time. For some reason, I wrote it as a pi. So what angle has a sine of 1 over radical 2? That's 45 degrees, so pi over 4. So x over 2 equals pi over 4 plus 2 pi k. Now, remember, sine, we have to do two quadrants. Here our sine is positive, Sine is positive in the first quadrant, so that gives you pi over 4. Sine is also positive in the second quadrant. If we put pi over 4 over here in the second quadrant, then this whole angle, let's see, that would be 1 pi, which is 4/4. Back one is 3/4. So we also have x over 2 equals 3/4 pi plus 2 pi k. Again, whenever you do inverse sine, you have to do 2 quadrants. Well, now we want to solve for x, so we need to get rid of divided by 2, so we multiply by 2. 2 times pi over 4 is 2 pi over 4, which is pi over 2. 2 times 2 pi k is 4 pi k. Multiply this in by 2. 2 times 3/4 pi is 6/4, which is 3/2 pi. 2 times 2 pi is 4 pi k. Now again, we find all the answers that fit between 0 and 2 pi. Well, if we start here, pi over 2 fits. Well, if I add 4 pi, since we're only going up to 2 pi, that's going to be way too big. So we're done there. Over here, 3/2 pi, well, that's less than 2 pi. That works. Well, if we add 4 pi again, that's way too big. So we just have those. 34 is the cosine of 2x minus the cosine of x equals 0. Now, a big thing to notice here, look at our two angles. This angle is 2x. This angle is just x. We don't like it when our two angles are different. So we need to change one of them. Well, when you see this 2x, we just got finished with double angles. We use a double angle formula. Since the other trig function we have is cosine, we want to use the one that has cosine in it. Well, the one that has cosine in it is 2 cosine squared a minus 1. So we're going to take out the cosine of 2x and replace it with that. Well, now we have this. Well, if we rearrange the order, let's put the squared one first, then this single one, and then our constant. Well, now it looks like a quadratic because we have a squared, we have a single, and we have a constant. Remember, quadratics factor like this when they factor. 2 cosine squared, the only way to factor that is if one of them is 2 cosine x and the other one is just a plain cosine x. Because if we multiplied, that would give us 2 cosine squared. Two factors of a -1 are 1 and -1. Since we want this to be negative, we want to put the negative opposite the 2. So it looks like that, because now if you multiply that out, the outside 2 would give you a -2 cosine x, the inside 2 would give you a +1, and that would add up to a -1, which is what we want. Now once it's factored, we set each factor equal to 0. And we're going to work each one of them separately. So like this one, we have a single trig function, just cosine, so we want to isolate it. So to get it by itself, we need to move the 1, so we're going to subtract 1. And to get rid of the 2, we're going to divide by 2, so it looks like that. The next thing to get rid of is cosine. To get rid of that, we do the inverse cosine. So this says what angle, I'm sorry, I'll write it down here. Right, this says what angle has a cosine of -1 over radical 2. I'm sorry, we're not radical. That's what's supposed to be a radical. Sorry, that's -1 over 2. Adding all kinds of stuff in. So what angle has a cosine of a -1/2? Well, 1/2, that's a reference angle of pi over 3, and cosine is negative in the second quadrant. If we put pi over 3 here in the second quadrant, this whole angle would be 2 pi over 3. So for that, we get 2 pi over 3. And remember, for cosine, we put a plus or minus in front. That takes care of our 2 quadrants, and a plus 2 pi k in the back. So we've got where we need to be on that one. Now let's go to the other one. Cosine x minus 1 equals 0. Again, there's a single trig function. We need to isolate it, so we need to move the 1 to the other side. Now, the next thing to get rid of is cosine, so we do the inverse cosine. So what angle has a cosine of 1? Well, cosine is x over r, so that's going to be 1 whenever x is 1. X is only 1 on the positive x-axis. So that equals 0 plus 2 pi k. Now, if we find everything that fits between 0 and 2 pi, if we start with 2/3 pi, that fits. Now, if we add 2 pi, well, if you're only going up to 2 pi and we're adding 2 pi, that's going to be too big. A negative 2/3 plus 2, well, 2 is like 6/3 if I take it. Now, you know the negative third is not going to work because we have no negatives. So if I have to take a negative 1/3 pi and a positive 6/3, so negative 2/3 and a positive 6/3 is 4/3. That fits because it's less than 6/3. If I added 2 pi again, that's going to be too big. Over here, x is 0. Well, that fits. If I add 2 pi, that doesn't quite fit because we're only going up to 2 pi. So that doesn't quite fit. If we go to 35, I get where I can see what's going on here. So if I put 35, let's see, 35 says sine x cosine x equals 1/4. Well, this is kind of tricky because we have two trig functions, sine and cosine, but if we get this equal to 0, that won't factor. Well, if you look at that, that looks kind of familiar, sine x cosine x. We had an identity before that said the sine of 2x equals 2 sine x cosine x. Well, this is almost the same. We're just missing a 2. What if we multiply both sides of the equation times 2? So I multiply the left side by 2. If I multiply 1/4 by 2, I get 2/4, which is 1/2. Well, now, this, as we said, is the sine of 2x, so let's replace that. Now we just have a single trig function, which is nice. So we want to isolate it. Well, it's already isolated. The sine is by itself. So now the next step is to get rid of sine, so we do the inverse sine. So those neutralize one another, so we're left with 2x equals the inverse sine of 1/2. So what angle has a sine of 1/2? Well, a sine of 1/2 is pi over 6. So our angle could be pi over 6 plus 2 pi k. And sine is also positive in the second quadrant. If we put pi over 6 in the second quadrant, this whole angle would be 1 pi, which is 6/6, minus 1/6, so that's 5/6. So we get both of those. Well, now we want to get x by itself, so if we divide everything by 2, pi over 6 divided by 2 is like times 1/2, so that'd be pi over 12. Divide that by 2, that's just 1 pi k. Same way, divide this one by 2. 5/6 times 1/2 is 5/12. And again, that divided by 2 is pi k, so we're right there. Now, if we want to find what fits, well, pi over 12 fits. If we add pi, that's like 12/12. 1/12 plus 12/12 is 13/12, that fits. If I add 12/12 again, that's 25. Well, 2 pi is 24/12, so that would be too big. Go to 5/12, well, that fits. If I add 12/12, 17/12, that's still good. If I add again 29/12, well, that's too big because 24/12 is the biggest. So those are our 4 answers. (37). This one has a couple tricks in it. So it looks like that. We're in degrees now. Well, here we just have a single trig function, so we want to isolate it. And when you isolate it, so we need to divide by 2 radical 3. And here's the first trick, kind of. If you look at this, that doesn't look very familiar. But again, when you see these have the same base, 3 and radical 3, we can divide top and bottom by radical 3. 3 divided by radical 3 is radical 3. 2 radical 3 divided by 3 radical 3 is just 2. Now that matches one of our triangles. So the next thing to get rid of is sine. So we do the inverse sine to get rid of that. So now we have theta over 2. Well, what angle has a sine of radical 3 over 2? Well, that's when the opposite is radical 3. That's 60 degrees. Now that's in the first quadrant. Remember sine, we have to always do 2 for sine. Sine is also positive in the second quadrant. Well, if we put 60 over here, this angle would be 180 minus 60, so that'd be 120. So theta over 2 could also be 120 plus 360k. So we have those two equations. Now to solve for theta, we need to multiply by 2. So if I multiply by 2, that'll be 120 plus 720k. Multiply this one by 2. 2 times 120 is 240 plus 720k. Now we want to find what fits between 0 and 360. Well, 120, that's between there, so that works. If I add 720, well, that's going to be 800. That's way too big. Here we have 240, that fits. If we add 720, that'd be 960, way too big. So this one just has those two answers. Okay. If we did 38, let's see, 38 is 1 minus sine theta equals cosine of 2 theta. We did one like this before. Notice one angle is theta, the other angle is 2 theta again. We don't like that. Well, we have an identity. We have double angle identities. If we pick one, since we already have sine, pick the one that has sine in it. Well, the one that has sine in it says that's cosine of 2 theta is 1 minus 2 sine squared theta. So we're going to put that in its place. Well, now I have a sine and a sine squared, so it's more than one trig function. So let's move everything to one side. If I move it left, so this is positive, I'll have a 2 sine squared theta. Well, now I'm going to have to subtract 1. 1 minus 1 is 0, so that's gone. So we have that minus sine theta equals 0 now. Well, now we still have two trig functions, a sine squared and a sine. So we want to try to factor. Remember, the first thing you look for is a common factor. Well, here, sine theta goes into both of those. So 2 sine squared divided by sine is just 2 sine theta. And sine theta divided by sine theta is 1, so it looks like that. Now we set each of those equal to 0. So now we're going to work them out separately. This one has a single trig function, so we isolate it, and it already is. Now we need to get rid of sine, so we do the inverse sine. So that says what angle has a sine of 0? Well, sine is y over r, so that's going to be 0 when y equals 0. Well, y equals 0 at 0 and at pi. So here we have theta equals 0 plus 360k, and theta equals 180 plus 360k. I said pi before, but I forgot we were in degrees. So we have those. Now here, again, we have a single trig function, so we want to isolate it. So we're going to add 1 and divide by 2, so we have that. Now if we do the inverse sine, gets rid of this. So what angle has a sine of 1/2? Well, if the sine is 1/2, That's 30 degrees. So that's 30 degrees plus 180K. We also want to put 30 in the second quadrant. That's 150 plus 180K. Now this one says find all solutions. Whenever it says find all solutions, we stop right there. These are our answers, because we can do as many as we want now. When it says all solutions, you actually get a stop sooner than the other ones. All right, let's look at 39. Now we did one a little bit similar to this one before. Notice our angles, we have a theta and a half a theta. Now we don't like that when our angles are different. Well, half means we have a half angle identity for that. Well, the half angle for identity for that is the square root of 1 minus cosine theta over 2. So it's sine squared, so we're squaring all that. Well, when we square a square root, we know it just gets rid of the radical. So it'll look like this. Now we really don't like this fraction over here, so let's multiply everything by 2. That looks a whole lot simpler. But now I have a cosine theta on each side. Let's move those to one side. So let's add cosine theta over here. If we add 1 to 2, that gets 3 cosine theta. But now we're down to a single trig function, just cosine theta. So we want to isolate it. We divide by 3. Then to get rid of cosine, we do the inverse cosine. So what angle has a cosine of 1/3? Well, that would be adjacent over hypotenuse. That means the hypotenuse is 3. We don't have a triangle with hypotenuse 3. So we need to do that on our calculator. So you make sure you're in degrees, and then we're just going to do second cosine of 1/3. And the calculator says 70.5. Now remember, for cosine, for our two quadrants, we put a plus or minus in front and a plus 360K in the back. And this is another one that says solve for all solutions. So we're done. That is what, all but one of the problems on 6.3.